Okay, so last week, what I intended to do here was to give you an overview of the entire hydroplate theory. There's quite a bit to it, and the intention here was to cover the basic phases of the theory, just to give you a chronological idea of what happens during each of these phases. And then after we do this, I want to go back and spend more time on each, maybe not every single one, but each of these important parts of the theory we'll spend, and we'll go into deeper discussions about and deeper explanations. So this is kind of intended as an overview. I don't want to be like super brief because I want you to understand a little bit about what's going on here. So I think it will help you give you an overview of what actually happens during the whole flood event from beginning to end, and actually what even occurs after the flood ends, because we're still basically in a recovery phase. So as we discussed, I think a little bit earlier, this theory was developed by Dr. Walt Brown. And basically in his book, if a particular theory can explain things in a way that explains things better than any other theory, then we start to have a really good confidence that the theory is the correct one. You know, that's the right theory. And so we also discussed that one criteria of a good theory is that you want to use very few starting assumptions. And of course, the starting assumptions of the hydroplate theory is the trapped subterranean water below a solid crust. That was put that way and created that way by God in Genesis. It's described in chapter 1, verse 6 through 8. So this is our basic starting assumption. We also said there was a couple other starting assumptions, that the earth is created good and there was no negative things in the earth like asteroids or comets or radioactivity or floods or avalanches, volcanoes, these sorts of things that have been detrimental or harmful to humans. So that wouldn't have existed at the end of the creation week. And what we'll see is that those are all a result of what happens as of the flood. So this is all a result of what happens as a result of the flood. And we also talked about that we believe that the sixth-day account of creation is true as recorded in Scripture. So there's many, many scientific evidences that confirm this, and we'll go through some of those as we go through the course of the class. So any legitimate theory allows us to also be able to predict or make predictions about what you might find. And if you start finding that these predictions are accurate, then again, it starts to give you a lot of confidence that the theory is correct, right? So if you can start predicting things, okay, because of this, we would think that this might have happened, or this could have happened. And so in the book, Dr. Brown has developed about 58 distinct separate predictions. And so if you start to see some of these predictions be confirmed, you can start really having a pretty good degree of confidence that this is the correct theory. And so some of these predictions that have already been confirmed is that we're finding now pooled pockets of water below mountain ranges. And this would be unexpected according to evolutionary theory, and would be unexpected because no water can seep down that far, that deep into the earth. And as we'll talk about, we talked about this a little bit, any deeper than 5 miles, water can't seep any deeper than that because the cracks in the earth are all sealed off or basically filled in because of intense pressures. Another one would be salt, would be found on Mars, and that actually has been confirmed. So if we see material ejected from the earth, some of it would have been salt that was in the waters, and it would have made it to other planets, actually. So we found traces of salt on other planets. Another is that asteroids would be found to be piles of rocks, basically floating piles of rock. And that's been confirmed. That's what asteroids are made up of. And then another one is that we would find detectable levels of carbon-14 in fossils. And that's found too. And we'll go through carbon-14 dating later, but it's an amazing way to date things. And if you see traces of carbon-14 in anything less than around 100,000 years, that's as long as carbon-14 can last. But carbon-14 is now found in all kinds of fossils and coal and oil deposits where it shouldn't be. Supposedly they're millions upon millions of years old, but there shouldn't be any traces of carbon-14 because of how fast carbon-14 decays. So we'll find that these are very distinct things that will give us a lot of confidence, I think, that these theories are correct. And so as we look at the events of the flood, it starts to become clear that a lot of scientific problems, in fact, dozens and dozens of them, can be solved. These are problems that befuddle the evolutionists. They always scratch their heads and they kind of ignore a lot of things. But when we put all these things together, this starts to solve a lot of those problems that are pretty difficult to explain otherwise. And so last week we really started by going through the first two phases of the flood. So on this chart here, we'll see that the first phase is called the rupture phase. The second phase is called the flood phase. And we did go through a good part of that last week. And so my intention with this was to kind of cover things, you know, rather briefly, but just to give you an idea of what happens during these different phases. And then, of course, we're going to go back and spend some more time on these things. So as we got to the end of the flood phase, this would be lasting probably several months. And this is where the extensive continental shelves form. We'll see on the chart here, this is where the erosion here starts to cause continental shelves. I know it's probably hard to see on the chart there. And we'll also see this is where most of the fossils start to form because of the sedimentary layers. All these sediments that are brought up during the flood start to bury animals and plants and create our stratolayers. And also that's where we'll see coal and oil deposits start. And through the right conditions, we can see that coal and oil and gas deposits can actually form rather quickly, very quickly. So that brings us up to kind of where we left off last week, and that was at the beginning of what's called the Continental Drift phase. So the Continental Drift phase basically is the phase where these plates or these continents will start to move apart from each other. And this is because of material inside of the Earth. So if we look at the cross-section of the Earth again, we see the mantle was below and the waters and then the crust and then waters above that. There's a certain amount of pressure that would have been compressing the rock underneath in the mantle because of all the weight above it. So rock has a certain amount of elasticity to it. It doesn't seem like it would, but under the right amount of pressure, it actually will compress a little bit. So under all this compression, when you all of a sudden relieve this compression or this pressure on it, it acts like a spring and it starts to pop up. So what ends up happening is where all this material is moved above the mantle when the fountains of the Great Deep burst forth, and then you can see that on the chart right here, is that all of a sudden the material that's underneath this area that's now exposed will now rise. It'll actually pop up rather quickly because all that weight is taken off. And this rupture path widens during the flood and causes more of this ocean, what is now the ocean floors, but the mantle below now starts to rise even more. And we'll see this when we look at the ocean floor maps, where you'll see this oceanic ridges are formed by rock that pushes up, and then the more movement allows more rock to be raised up. And so it's kind of like a runaway train kind of situation here, where more movement causes more melting causes the ability for more movement, and it goes down and it starts to actually melt in the inner part of the Earth. So the Earth didn't start out molten, it became that way as a result of the flood. So there's several passages that are really interesting, like Psalms 18:15, which says that the valleys of the seas were exposed and the foundations were laid bare. So I think that's referring to this. It has a clear reference back to the flood, and that's what's happening. I think the mantle now is being laid bare. The foundations of the earth are laid bare. Very interesting passage there. So now as the mid-Atlantic ridges start to rise, we have plates now that have eroded away from where this ocean ridges are starting to rise now. Because of that, the plates are still somewhat lubricated with water underneath them, and also a lot of sedimentary materials that would give them a certain amount of ability to move. What's the word I'm trying to find here? slipperiness, the plates now start to move away from each other. So now we see what forms the continental drift phase. And so the flora rises in the Atlantic Ocean about 30 miles, actually, which is quite a bit. And so when it started to rise and the plates started to move away, more weight was taken off the foundations or the mantle below, which allows more rising to happen. So it starts kind of a runaway freight train. And so it continues along that rupture path. And we showed a map of the Earth earlier showing the ocean floors, and this continental or this mid-oceanic ridges actually wrap all the way around the Earth, all the way around the globe. So we also will see that the ridges, the mid-oceanic ridges, have some very strange features to them that don't look like mountains today on Earth. They have been basically have a lot of cracks and fractures within the rocks. And this is because rock has a lot of compressive strength, but its tensile strength, which is the ability for it to be pulled apart, is much lower. So as this rises up, now the rock that's there can split apart, and that would cause these ridges to start to form, or these cracks to start to form, which is what you see on the mid-oceanic ridges. You don't see this in any other mountains on Earth. So then we've also discovered something called the Mohorovicic discontinuity, and they've shortened this to the MOHO, so thankfully you don't have to remember Mohorovicic. But basically it's a boundary line between the crust and the mantle. So today, when we take seismic measurements or seismic waves, it travels much faster below the MOHO and above, because the granite and basalts are less dense than the mantle material, which basically it confirms that there's a boundary between basically our continents and the mantle below, and that's called the MOHO. And again, we'll get more into that later on, but it's down there, and this now explains why. The hydroplate theory can explain why there's such a distinction between the seismic waves above and below the MOHO. And then at the end of the continental drift phase, buried layers of vegetation are rapidly compressed and heated, and this is precisely the conditions that are necessary to form coal and oil rather quickly. We can produce this in laboratory experiments. So now we'll see that coal and oil can be produced in a matter of months. It doesn't take millions of years to do this. And so the sliding hydroplates are almost perfectly lubricated by water until the water starts to escape them underneath as they slide away from the mid-oceanic ridges. And so the plates are going to move apart at around, Dr. Brown estimates, around 30 miles an hour, which is kind of amazing when you think about these huge plates moving at that kind of speed. The energy that would have been created and the motion of that is just astounding. So as the Atlantic Ocean floor rises, or what will become the Atlantic Ocean floor, there's a lot of heat formed below there, causes more melting of the interior of the Earth. And what ends up happening on the opposite side of the Earth is that what is now the Pacific Ocean is basically sucked downward to compensate for that. So there can't be a void inside the Earth. So as the Atlantic rises, the Pacific has to rise as well, or sink, be sucked in. And that's exactly what we see on the Pacific Ocean. We see a plate that's covered. The Pacific plate is actually underwater. It's not exposed on the top now. And as it's pressed down, cracks start to form all the way around the edges of the Pacific Ocean, tension cracks, which are very deep trenches. So this is where what's called the Mariana Trench and all these deep, deep trenches that surround the Pacific Ocean come from. And this today is called the Ring of Fire. And this is where most of the Earth's earthquakes are concentrated in this area, because there's such a disturbance in all of this motion. There's such a disturbance there. It causes all these earthquakes to happen, because the Earth is trying to get itself back into balance again. Basically it's in an out of balance condition. So we see that there's a lot of earthquakes that would have happened, a lot of them at first, and then they would dissipate as the Earth starts to get a little bit more back into balance. We'll see fewer and fewer earthquakes as we move on, and fewer volcanic action. So again, the denser parts of the center of the Earth do sink to the middle of the Earth, forming the dense core. And then the shifting of so much material now toward the center of the Earth would compress the Earth a little bit. So we have a lot of this. We'll go through how much how much material from the Earth would have been ejected out beyond the Earth's atmosphere. But there would have been a somewhat of a compacting of the Earth during this time, and so much of this material that shifts toward the center of the Earth because of melting would also increase the rotational speed of the Earth somewhat. So today the Earth spins at a rate of 365.256 times per year. That's where we get our 365.25 days in a year. Why we need a leap year every 4 years to make up for that quarter, right? So that's why February has 29 days every 4 years. But previous to that, I mean, before the flood, the spin rate should have been a little slower, and so would cause this increase in spin rate causes the Earth to have more days per year. So if we work backwards and we assume or we can show that the Earth had a slower spin rate, we would have had fewer days per year faster. Oh, yes.
Just looking at what you're explaining, and to me that would make it sound like the Earth was bigger before the flood.
Yeah, we ejected material out, so but also yeah, it's going to collapse in, and as the internal part of the Earth melts, heavier parts of what's melted will sink toward the center, and it'll kind of compress things a bit. And in the book, Dr. Brown shows an illustration of a figure skater. When a figure skater starts to do a spin, they have their arms out, they'll spin rather slowly, but as they start to bring their arms in closer, so you're more compact, what ends up happening? The skater starts to spin faster. And so there's scientific reasons behind this where the Earth's spin could have increased. And there actually are scientific reasons for a longer day, prior to the flood, and also historical records that refer back to a 360-day year prior to the flood too. We'll go through that again in some more depth. So again, I think that the spin rate of the Earth has changed. So basically, at the end of the continental drift phase, now we also find what's called the compression event. Now, the compression event maybe only lasts a few days, maybe a few hours. We don't know for sure. We can't tell. But eventually, these sliding hydroplates start to run out of water underneath them, and they start to run into things that cause resistance. So as the lubricating water beneath the plate was depleted, and also the plates collide with something, it would have experienced or would have produced what's called a compression event on the leading edge of these plates. So the compression event is buckling or crushing or thickening of each plate on the leading edges of the plate, and this would push up rapidly mountains up out of the Earth and up out of the water, and this would have maybe happened just within a matter of a few days. So all of a sudden, the compression event causes all this rising of the mountains. And we see too that on top of the mountains or in mountains, and really all around the world, these layers of the strata layers that would have been recently laid down are all still wet. They're still soft. During the compression event, they get compressed horizontally. And this is why we see bent and sometimes folded strata layers all around the Earth. Evolutionists will tell you that over time it compresses these rocks horizontally, but if they're solid rock, what would happen? They would crush. They wouldn't fold the way they do. I'll show you some stunning pictures of this later on in the class when we get to that section of this. But this explains, again, why you would see these folded patterns in the strata layers that are perfect. I mean, they go up and down in many cases, and the layers are perfectly even throughout all these bends and folds. So it wouldn't happen if it was a solid rock at that point. So now these forces would crush and thicken the plates to push up mountain chains, and that's also why we see fossils of sea life on top of mountain chains all around the Earth. So today we can find fossilized shells and sea life on top of very high mountains. I mean, much higher than current sea level. I mean, how did that get there? I mean, it was like, is there any explanation why we find fossilized sea life high on mountains? And as we looked at a map earlier too, the mid-oceanic ridge in the Pacific Ocean seems to disappear underneath California and the western coast of the United States up through Alaska. And this is why the formation of the Rocky Mountains is so dramatic, because that's the leading edge of that plate, and we push these mountains up rather quickly. And now that we have these deep basins that open up and the mountains are pushed up, it now gives a place for the water to go. So this is the answer to this question: where did the water come from? I think we know where the water came from now. And after the flood, where does it go? Why isn't the Earth still completely covered by water? Well, now these deep ocean basins open up, and now it has a place now for the water to drain back into these ocean basins. And as they do, we'll see that there are also large basins of water on the land that are left as well. And I'll get to that in a second. But you'd see quite a bit of the water that drains back into what now is the Pacific Ocean, especially. Pacific Ocean's huge, absolutely huge. It's deep and it contains a lot of water. So basically, this is where that water is now. This is where that water went. This is also now because of the water draining in the high mountains we have now and the huge ocean basins that we have. And this is why God can never destroy the earth again by a flood, or why he states he'll never do it again. It's not really possible now. We can't really flood the earth. I guess he could do it by a miracle, but in present state conditions, we have much larger oceans and much higher mountains, which make a future flood impossible under current conditions. And then this rising up of the mountains out of the waters quickly explains Genesis 8:1, where God says that he sent a wind over the earth and the waters, as the waters receded. So as these mountains were quickly pushed up, this would have produced a huge amount of displacement of the air, which would have created winds. And because of these mountains being pressed up, it would have created a pretty good amount of wind. So I think this makes perfect sense. I think as we just said, this horizontal compression of the layers explain how we find these folded or bended stratolayers all over the world. Actually, they're everywhere. You can see them in our mountains here that just aren't even very far from where we're at right now. So then the fourth phase starts. And part of the third phase, part of the compression event is that the Earth now has so much displacement of material in its balance that the Earth will start to roll now. So the Earth actually has a roll of about 34 to 57 degrees is what they estimate. So the sudden formation of these mountains starts to cause a big imbalance on the Earth, causing the Earth to slowly rotate. And remember we talked back last week about the frozen mammoths that we find here will form during the rupture phase. This explains now why they're still frozen, or they remain that way, because the Earth rolls into these fossils, or these frozen mammoths and rhinoceroses and many other animals actually have been found in layers of what's called muck, which is basically mud and decaying plant material in Siberia and northern Russia and into Alaska. So that's an area where these animals wouldn't have lived. Rhinoceroses they don't live in the snow. Because of long hair on the mammoths, they assume that they would live in snow in colder areas, but it's not really the case. Again, we'll get into that when we get into talking about that deeper in the coming weeks here. So now we have the upward surging subterranean waters were choked off, and now the plates start to settle back onto the chamber floor. So they've been pushed up quite a bit, and now because of all this weight, they'll now start to compress back down. And now with this newly opened basins between the continents, we'll see that sea level was lower, and this allowed land bridges between the continents, so that when God says to Noah after the flood to repopulate the entire earth, we actually had a way to do that. This probably lasted for a number of centuries after the flood, but there were land bridges. And if you look at, again, the map, land bridges between the continents, if you look at a map of the ocean floor today, you'll see there's like this massive land bridge that if sea level was a little bit lower than it is presently, you could migrate from Alaska or from Siberia and Russia through Alaska down to North America. So these continents were all interconnected, I believe, after the flood, and then after the massive amounts of settling of the mountains back into the mantle would have pushed up the ocean floors, which had raised sea level and would have cut off these land bridges. And again, it's pretty obvious when you see it, when you see a map of the ocean floor and exactly how shallow the water is between Alaska and northern Siberia, for example. So during the flood also, the floodwaters would have swept up a lot of vegetation and produced what's called methane. And much of this methane is combined with cold, deep ocean waters to become vast amounts of what are called methane hydrides. And methane has been known, it's the main component in natural gas, and has been discovered off our coastlines. And again, there's a logical reason for why they would have formed in the way that they did. It's actually a huge reserve of energy. If we could tap into it, this would be a great reserve of energy. And then also we'll see plateaus form. So we see plateaus like the Kaibab Plateau here in Arizona. We see different plateaus now occurring that don't seem to make any sense whatsoever. But what ends up happening to form plateaus is you have huge mountains with lower areas next to them. The mountains are so heavy that they push down, and then there's still molten lava, basically rock below that's melted, that'll push it underneath other areas and it'll push it up. And so you'll see kind of like a hydraulics, and we'll see plateaus can quickly form because of this. Yeah, we'll get into that a little bit more when we get a little further on. So this rolling of the earth explains now why we see fossils where they shouldn't be. We see deep below the earth, we see fossils of temperate or tropical plants and things underneath the polar ice caps. It, again, shouldn't be there. I mean, what explains why we find this kind of vegetation that shouldn't be where it is? They shouldn't be at these latitudes. But as the earth rolls, we'll see now that makes a lot of sense. And then some of these post-flood lakes that would have formed in the depressions of the newly formed continents would have contained a lot of water. And there's several examples we'll show of this. But some of these post-flood lakes would lose some water by evaporation, but they would also gain water because of rainfall and drainage into them. And so what ends up happening is that if the right conditions happen, so there's two huge lakes up in the northeastern Arizona area, and these two lakes, you can see them when you know what to look for, suddenly breach. This is probably several hundreds of years after the flood, the end of the flood, but they breach and wipe off, basically, they scrape off, it's called the Great Denudation. They scrape off about 2,800 square miles of material above what becomes the Grand Canyon. So huge amounts of water rush as these lakes breach. And Dr. Brown discovered them and he named them Grand Lake and Hopi Lake. But as this happens, this would have swept huge amounts of sediments off what would become the Grand Canyon. And as that happens, there's a surge upward, same thing. You've got a lot of pressure pushing everything down, compresses it. All of a sudden it's all taken off. It pops up rather quickly. And you can see this by looking at photos, like Google Earth photos of the northeastern entry to the Grand Canyon. You'll see what's called the funnel. And it looks exactly like what you would expect. Had a huge amount of water gone through that and eroded away. And now we see the Grand Canyon popping up. And there's many odd things in the Grand Canyon that make no sense when you say, oh, a river carved the Grand Canyon over millions of years. Okay, this is the story. You go to the Grand Canyon, that's what the tour guide's going to tell you. This canyon was carved out over millions of years by this Colorado River. Well, there's numerous aspects of that make no sense. Some of there's barbed canyons that actually go backwards, to what you would expect. I mean, there's all kinds of things.
There is one staff that presents tours from the
yeah.
And that's
Yeah, it's pretty amazing when you see, when you start to see all this. Again, it explains the formation of the Grand Canyon. And it didn't happen as a right after the flood. This was probably some centuries after. We don't know. There's no way to know for sure. And in these lake beds that would have drained, we now find some other unusual features. We find Monument Valley forms as a basin of one of these Great Lakes when the water drains out of Grand Lake. And we know that that's a very unusual part of the Southwest. Very unusual geology there is found there. And we also found just the right conditions will exist where wood will petrify. And so we see this extensive amount of petrified wood due to the unique conditions that are found right after the flood. And these petrified forests are now found at the basin of what was Hopi Lake. And we'll go through that a little bit later. And so all this mass imbalances on the Earth today causes imbalances which cause the earthquakes that we see today. It's the root cause of all of our earthquakes. It's the slow shifting of all this material. And a lot of this phenomena has been misinterpreted to support what's called plate tectonics, the movement of plates. And we'll get into that a little bit too, as why plate tectonics doesn't make any sense. So the mountain ranges and the raised plateaus happen. Then an ice age occurs. And an ice age occurs when specific conditions are met. It takes warm oceans and cold continents. And so the sliding hydroplates would have generated a lot of heat, as did the movement within the Earth. And this would have caused the rising of the temperature of the oceans. And there would also have been floods of lava spilling out, especially into the Pacific floor. And today there's about 40,000 volcanoes at the base, at the bottom of the Pacific Ocean floor, which is pretty interesting. So just the right conditions happen to heat the waters enough, and you have cold air, cold continents. So you find that there's huge amounts of snowfall now. And this is what we'll get into now. These conditions can produce an ice age. And so some of the glaciers that we see today around the Earth are a result of the ice age, the last ice age. So that gives us now, I think, a pretty good, hopefully, overview of the hydroplate theory. And again, I did this primarily so we can get a good chronological feel for what happens and what events and what times that they occurred during the flood. So now I want to go back, and now we'll start going through some of these things in some more detail as class progresses. So as we look deeper in each of these phases, again, I want to explain them further. Again, the rupture phase that we've kind of discussed, a crack happens in the Earth. Again, I think this isn't a ticking time bomb state. I don't think this is something that was inevitably going to happen. I think this is something that's due to God causing this to happen because of his extreme, I think, anger of what was happening right before the flood. I don't want to get into that. It's pretty interesting there too, but remember how Genesis 6:7 says he's going to wipe out all of mankind by a flood because of the evil and the wickedness of mankind during that time frame. So again, I think God knows what's going to happen. I think he obviously is brilliant beyond brilliant. I mean, he knows what's going to happen. So he causes this crack to happen. And again, this starts a devastating and catastrophic sequence of events. And we'll find, as we know now, I think, from looking at these last slides, it's just much more than just flooding the Earth. It's a whole lot more than just that. So there would have been a huge amount of pressure in these chambers due to the waters of the Great Deep being in the supercritical state, which we talked about, and I'll review a little bit more on that as well. Give you a little bit more details about exactly what that is. So it would contain huge amounts of energy in the trapped waters below these plates. And this would have caused a lot of dissolving of minerals on the floor and the ceiling of the chamber. So here on this ceiling of the chamber, there would have been started to be a lot of sediments that come out during the centuries prior to the flood and would blanket and also dissolve some of the mantle below. So this is your mantle below and your plate here. So as that occurs, there's say, a huge amount of sediments in there, but it also would now start to thin the crust a bit. So as we see, the crust will thin slightly, and this now starts to put the crust in a lot of tension. So kind of like a rubber band, as you start pulling a rubber band, you start to get a lot of tension in that crust. And granite has good compression strength, but very weak tension strength. This is, again, a characteristic of rock. In other words, you can pull it apart a lot easier than you can crush it. So this eventually can cause the failure, causes the crack. And eventually, again, this crack developed on the surface and raced around the entire Earth in a matter of, Walt Brown, calculates just a few hours. Wouldn't take them long. So there's great amounts of minerals in the subterranean chambers would have thinned these plates. As you watch this animation, watch the plates thin a little bit. And now this starts to put tension on that plate. So this is the cause of why there's so much tension in these plates. And so like a stretched rubber band, there's a lot of energy here. It's like a spring waiting to snap. And so once this crack speeds through the granite, the plates would snap back rather rapidly. And this would then produce a very quick gap in the plates, allowing all this violent explosion of water and sediments to be exploded out of this crack. And it seems like when you talk about the fountains of the great deep bursting forth, or the springs of the great deep bursting forth, as said in Scripture, depending on which translation you use, you can look to the Hebrew word for fountain or spring. It's Mayan, and it means a fountain, basically, or it means a spring or a well. So I think this is a pretty appropriate word. This is a huge amount of pressure that's relieved and opens up, now allowing the fountains of the great deep to happen. So once granite is ripped open, there's a high pressure of the supercritical water that happens basically right below the crack. So we had a huge amount of pressure here, and all of a sudden, right below the crack, that pressure is going to drop basically to zero. There's going to be almost no pressure there at all of a sudden. And this would have caused a great deal of rushing of waters out of that crack. So this is, again, gives us the amount of energy, some of the amount of energy that shoots this material up into our atmosphere and actually beyond our atmosphere. And so to illustrate this concept, think about a tube of toothpaste, and you take the cap off the toothpaste and you squeeze the toothpaste pretty hard. What's happens? It doesn't break the tube, right? Toothpaste starts shooting out of the end of the tube. Now take your tube of toothpaste, the cap off, and whack it with a hammer. All of a sudden, boom, you're going to find huge amounts of toothpaste on your wall somewhere, right? Well, that's kind of what's happening here. There's just this huge amount of pressure that all of a sudden happens, is this huge drop in pressure, because there's an opening now in this crack, and that's where the water goes. That's where the water is going to go. And of course, Genesis 7:11 records this, as we talked about. So again, he sends rain for 40 days and 40 nights. And this is the first time that any event has been recorded so precisely down to the day. We'll go through a timeline, a little bit more of the flood as well. But this is calculated out right to the day. And we can then produce a really accurate flood timeline as well. So, but they obviously, this wasn't just an ordinary rainstorm. I mean, the rain we get today is from clouds. This wasn't from clouds. This was because so much material was ejected up into our atmosphere and fell back down as torrential rain. And huge amounts of sediments and water would have rushed across the plates above the crust, again, trapping many animals and plants, causing them to eventually be trapped into the sedimentary layers, creating our fossil layers. So to more completely really understand just how much energy might have been in the subterranean chambers, and one of the reasons it literally exploded out when it started, I just want to look at just briefly what happens to water when it's heated, and just how much energy would have been released when the crust ruptures. So again, we talked earlier about supercritical water. We're now going to just say a little bit about just how much energy this would have been. So we're all familiar with water when it boils, right? It's probably boil water on almost a daily basis, right? So what ends up happening is the liquid transforms into a gas or a vapor because it's so hot, and that creates the bubbles, creates the boiling of water. And so this happens when the liquid's vapor pressure equals the surrounding atmospheric pressure, and this causes bubbles to form and rise through the liquid. And boiling, just to note, it's a physical change. It's not a chemical change. It's not a change to the chemicals that make up water, the hydrogen and oxygen. It's a change of the physical state. So the molecules remain the same. They're just in a different state. So looking at boiling water, it will remain at the same temperature, which is 212 degrees is your boiling point of water, at sea level, as long as the pressure is allowed to remain constant. So in other words, as long as your lid's open, the water really isn't going to get any hotter because energy is released out of the top of the water. So the water will stay at the 212 degrees. So if you boil it, you apply more heat, it just boils more rapidly, but the water temperature doesn't really change. As long as it's allowed to escape in an open container like this. So we'll see it burst out the top, but that's where it goes. Now, what would happen if you place a cap on the container? It's a different situation now. So now both the pressure and temperature will now increase. The pressure of the interior of this sealed enclosure now. And also now the temperature of the water can now increase. So since all the mass within the container is trapped, the density of the water vapor increases while the density of the liquid decreases, and eventually it gets to the point where we talked about supercritical water being half gas and half liquid. So it's an equal state where both of them are equal. So that's at the point where it becomes supercritical. And so now we see that microscopic droplets are suspended in the midst of high energy gas, and now because the liquid density and the gas density are equal, it reaches this point of being supercritical. So the point to realize here, and we'll stop here, is that the potential energy stored in this water is tremendous. And I'll talk to you a little about potential energy versus kinetic energy as we start next week, as we run out of time. So we have questions.
Much like a pressure cooker.
Yeah, that's why a pressure cooker. Or think about, this is probably, didn't quite get to this, but think about we've probably all experienced an overheated radiator on our car, right? So your radiator gets super hot, and you take that cap off, what happens? It's an explosion out of there. And that's kind of really what's happening. There's a tremendous amount of energy here. So anyway, thank you. Any questions, let me know. Appreciate your attendance. You bet.